All right. Shut up! All right. So we just had reading for today, right? What did we read about?
Methods, classes, variables.
Did we do array lists?
No, there's a little bit of static stuff in there, but
Okay,
it's
gotcha.
very minuscule.
What's new in Keynote? All right, so we want more practice with all right, right. So last time we talked about static versus class methods, right? So, well, static versus class members. So we have two different sides to this. One is when we are defining something. So when we're actually creating the class, defining the blueprint, we can have class, so we can have static or non-static fields. So what are fields? What are fields as they relate to classes? This should be right there. These are the variables owned by the class. Those are the fields, right? Okay, fields are the variables that are part of the class. What are the other two kinds of things that belong to classes? Classes are made up of three members, fields, and what are the other two things? Constructors and methods. Okay, good. So we can have either static or non-static fields, and we can have static or non-static methods. When we have a static method and we're looking at it being defined, what will we see? The static keyword in front of it. So when we're defining a method or we're defining a field, if it's going to be a static field, we put the word static in front of it. If it's not going to be a static field or a static method, we don't put the word static in front of it. That's what we're looking for when we see the definition of the field or the method. All right? This is different than when we're actually using it. So we define something, and we never actually have to use it. We can write, if we go back to our code here, we can write this fraction class and then choose never to ever create an instance of a fraction. What, you guys can't see that? Get your eyes checked.
Sure, can I get? I'll grab my binoculars.
All right, so we can create this fraction class and then choose to never, ever, ever, ever create an instance of a fraction. Right? We wasted our time. We made the blueprint. We defined it, but we never actually used it. Okay? So we have two different points in time that we're talking about here. We're talking about one is the definition of an object, for example. The other one is when we actually go to use it. All right? So up to this point today, we talked about defining fields and methods. So when we're defining a field or defining a method, we either choose to use the static keyword or not the static keyword. And that flags it as a certain kind of field or method. All right? Now, when we look at the definition of a field, so for instance, here's a field right here. We don't see the keyword static there. That means that guy is a non-static field. That gives us all the information we need to use that field. Similarly, we come down to a method. Here's the definition of a method, add. Okay, this guy does not have static in front of it. It tells us everything we need to know about how to use this method. All right, make sense from the definition side? So now when we go over to the use side of this, here's me calling, where am I calling frac? Here's add. So since the add method, this is me using the add method. Since the add method did not have static in front of it, I need to call it using an instance of the class in which this method was defined. This method add was defined inside of a class called fraction. So that means in order to call add, because it does not have static in front of it, in order to call that method, I'm going to need an instance of the fraction class. So out here, I have an instance of the fraction class that I'm using to call the add method. That make sense? So whether a method or a field is defined as static or non-static tells us how to call it. All right, so if I were to randomly come in here and say, did I give ourselves a... I didn't, so I'm gonna come up with a stupid example real quick. So I'm gonna say static void do something, and this guy will just do a system.out.println. I am a static method. All right. So now I have a method. At this point, we haven't even discussed why I would create a static versus a non-static. That's the next discussion. All right. Right now, just assume you want to, for whatever reason. All right. So in this case, I've created a method. It has a return type of void, and I have flagged it as static. That tells me everything I need to know about how to call that guy. So since that guy is a static method, how do we call him? Remember, there was a super high risk that we were going to have a quiz over these exact phrases today. So everybody should, this should be, didn't I say, make it part of your soul last class?
Yeah.
So something like that. So how do I call class or static methods?
Dot.
They're all going to have dots associated with them. Go ahead.
You just assign a variable to them?
Look.
Inside of
All right, so we're going to say this together.
from the dot.
All right, so static are called using the name of the class in which the static member was defined. Non-static are called using an instance of the class in which the member was defined. Static are called using the name of the class in which the method was defined or the member was defined. So in this case, I have a static method who is defined inside of a class called fraction. I call this guy by saying fraction dot, the name of the method. Okay, because it's static. Static means it's a class method. Means it's owned by the class, and therefore the class calls his own method. All right, so out here, for no explainable reason, I'm going to say fraction dot do something. We have no logic behind why I made that static. I just did. And because I made it static, we call it using the name of the class in which it was defined, as opposed to an instance of the class in which the method was defined. So add was a method defined as a non-static method. So I call it using an instance of the class. So non-static methods, I would call instance methods. Let's get that on a slide. I probably already have it on a slide, but let's just put it on another slide again. Yeah, here, it's on the last slide. Static methods or fields are called class methods or fields. So when it's static, it means the class owns it. So a lot of times they'll call it a class field or a class method. Non-static methods or fields, these guys are owned by instances of the class. Every copy of that class, every instance of that class gets their own copy of those fields and their own copy of those methods. Right? That makes a lot of sense for like fractions, right? Every instance of a fraction should have his own numerator and denominator. We don't want to set a single numerator and denominator and all fractions now have that identical numerator and denominator. We want to have different fractions, right? Right, so fractions have a non-static numerator and a non-static denominator. That means every instance of the fraction class will get their own copy of the numerator field and their own copy of the denominator field to hold that particular fraction's numerator and denominator. All right, so be prepared that I will sometimes call them class methods or class fields, and I will sometimes call non-static things instance methods or instance fields. All right. So questions about this guy. Now I could, let's say if I wanted to give myself a convenience function. I'm gonna change do something, and we're gonna call this guy make fraction. Actually, let's call it build fraction. And this guy's going to take an int numerator and an int denominator. And he's going to return a fraction. So I can return a new fraction built with the numerator and the denominator. All right, so this is kind of a convenience function for us where we have a class method, a static method that happens to return a fraction. His name is build fraction. And what does he do? He takes in a numerator and denominator and he builds me a brand new fraction with that numerator and a denominator. Make sense? Why might we want that? Well, let's just call it maybe out of laziness. But now what I can do is I can come up here and I'm just going to steal the inner guts of that guy. Actually, let me put it on a second line. I'm going to say fraction Mike2 is equal to fraction dot build fraction, and I'll pass it those two things. This is good. Oh, I need to have him take longs because our numerator and denominator are both longs. All right, so this is for the world where we're afraid of using the new keyword and calling the constructor directly. I can ask fraction to have a special factory for building fractions. I can pass him the numerator and the denominator for the fraction, and then magically inside of this method, he'll spit out my built fraction. I'm not sure it makes tons of sense, but if you're afraid of the new keyword and you only want to have to look it up once, you can look it up once, write it inside of here, and then whenever you want to build a fraction, you just ask the fraction class to call its build fraction. This is like a one-time, one-off factory. So it exists one time, it's owned by the class, and we say, fraction class, here's a numerator and denominator, build me a fraction out of these, and he'll spit a fraction back out. Go ahead.
So would you use a class method when that method would be doing the same thing in every instance?
Yes.
An instance method when we need instance-specific data?
I think that's an excellent way of putting it. Yeah, you would use class methods when it doesn't matter which instance it is, it would always do the identical thing. You would use instance methods or instance fields when individual instances need to operate on their specific data. I think that's a very good way of putting it. All right, so questions on how to build static and non-static stuff. Go ahead.
So could you go over the clarification of why would we use static methods and like the context for using static methods over non-static?
Yeah, I'm about to do that now. Yeah, we haven't covered it yet, but that's what we're about to do. But right now, we know how to. We know if you were to be asked to write a static method, you could do it. If you were to be asked to call a static method, you could do it. If you were to be asked to write a static field, you can do it. If you were to be asked to use a static field, you'd be able to do it. Okay. Now, half of you are lying right now. I can tell you that from experience teaching this class. Memorize that cadence. Instance methods are called they're defined without the static keyword, and they are called using an instance of the class in which the member was defined. Class fields, static fields. These guys are defined with the static keyword and are called using the name of the class in which the method or the field member was defined. All right, that unlocks the entire Java programming language to you. Is if you can identify the definition of two things and say, I know how to call this because of the presence or absence of the static keyword. Make sense? All right, so what we're going to do here is we're actually going to use, I'm going to go into Java character class. All right, so first of all, I'm in the character class for Java, and here's our fields. So these are the variables associated with the character object. Notice that we have a whole lot of statics there. Static out in front of almost every one of those. In fact, I haven't seen one that doesn't have it out there. All right, and then we have method summary. So we have static in front of almost every one of them. Okay, so we're convinced that the character class has a whole bunch of static stuff inside of it. Okay, and I promise you if I showed you the integer class, you'd see the same stuff. If I showed you the Boolean class, you'd see the same stuff. If I showed you the double class, you'd see the same stuff. So now we'll go back here and we're going to say, there exists the following classes. Byte, short, int, long. Actually, it's not. It's integer. Character, Boolean, float, double. Yeah, let's call it that. All of these classes exist. Now, what do these remind you of? What do these look a lot like? Primitive types. Okay. So these guys, there exists the following classes for each primitive type. Now remind me, what's a primitive type? Go ahead.
It can just hold a value. It doesn't do anything more than
Yep. Primitive types are built into the language and they can only hold a value. That's the extent of their talents. Okay? Now, we just happened to look at the character class here, and we noticed a bunch of static stuff in there, right? Okay, we saw a bunch of static stuff inside the character class. All right. What does static mean? What does static imply? How would I call a static field? Go ahead.
It means that it's like more when I hear the word static, I usually imagine something that isn't changing, something that doesn't.
How do I call it? How do I call a static field?
A static remember in the form of the class.
Yep, call it with the class name itself. How do I call a static method? Class name itself, right? So if something is static, I reference it using the name of the class in which it was defined. So all of that static stuff that I just saw in the documentation for the character class, and I'm presuming most of us in here, I may have used it in some example, but let's just assume that most of us have never used the character class in here for this example, okay? So I just showed you a page that presumably you've never seen before. You saw a bunch of static crap on that page. Now you know how to call it. You know how to call it because it had static in front of each thing. If it was a field, you're going to call it using without the parentheses. So for instance, pun intended, because I haven't talked about public, private, protected stuff yet. Here's a field here called numerator. That guy does not have static in front of it. That means it's owned by instances of the class. All right. To your point, it needs to keep individual specific data relative to each instance. So I would access this guy using an instance of the class. So I can come out here and here we have a fraction here called Noah. So to get at Noah's numerator, I would say Noah dot numerator. So I can say long chancery is equal to Noah dot numerator. All right, so now I have a local variable called chancery that I'm setting equal to the numerator field, the numerator instance or non-static field associated with this particular instance of fraction called Noah. Make sense? So that's me accessing a non-static field using an instance of the class in which it was defined. So this is how I call fields. Notice it's the name of the field, no parentheses, because fields aren't functions, so there's no parentheses, as opposed to this is how I call an instance or a non-static function. Function name, passing any parameters, but there will always be parentheses there. Make sense? All right, so I have the character class that has a bunch of static stuff in it. That tells me everything I need to know about how to access those things. All of that static stuff is accessed with the name of the class, so it'll be character dot whatever the name of the field is. Character dot whatever the name of the method is. Make sense? All right, so now a few minutes ago I made a little fraction builder thing in the fraction class that was kind of a lazy man's way of generating fractions without having to directly call the constructor in case you're afraid of constructors or something like that. All right. And I referenced it as kind of like a factory, right? We toss a numerator and denominator to it. You know, it cooks it, does whatever it's supposed to do, and spits out a fraction to me. That make sense? All right. So it exists one time. There is a single fraction building factory. That I walk up to the door of that guy, I toss in a numerator and denominator, he spits out a fraction. And if somebody else wants to use it, they're using this exact same fraction factory. Same thing's true here. With the character class, with the byte class, with the short class, whatever it is, there exists one character class. And inside that character class, we have a whole bunch of what I often refer to as factory methods. These are class methods that are meant to do something, but we'll always call them using the name of the class because they only exist one time. All right? Why do you think, and I'm telling you that all of these classes here are going to be filled up with static stuff. Why do you think we have, well, before we answer the question of why are they filled with static stuff, let's ask, why do these classes exist? Why do I have a character class? Let's just pop this open real quick and go and look at, so here's some of the functions in here. We have like a, here, isDigit. So the isDigit method takes a char as a parameter and spits out a Boolean, true or false, if that guy is a number, a digit. Let's see. Here's an isLetter one. I'm just picking like ones that kind of make a lot of sense, right? isLetter, I give it a char. It tells me true or false whether that guy is one of our letters, A through Z, upper or lowercase. Go ahead.
Does it give operatives that can be applied to one character in a string, essentially?
Well, that is, okay, so in your what you just said, you're saying like isLetter is an operative?
Yeah.
Okay, so yeah, so this is a function that can operate on a single char that may have come from a string, or I might have just hard-coded a char. Yeah, but it's a single char primitive type. That's what these guys are. Yeah, so that's another observation to make here. Notice that most of these take as a parameter a char. They need an input. Not dissimilar to my example of the fraction factory, where in order to build a fraction, my fraction factory needed me to toss in a numerator and denominator. He needed ingredients to cook a fraction. Make sense? This character class, if I want him to tell me whether a particular char is a letter, he needs me to give him that char. I have to give him the ingredient, the input. Okay? So getting back to that question, why do these guys exist? Why do all these classes exist? This gets us an insight into the mind of why we might create a class filled with static stuff. Go ahead.
I think it probably makes it so that you can operate on different values more effectively.
Okay. In this case, values being chars, right? Okay, so we have, so at the very least, we can call the character class a convenient way of operating on chars. Okay, I mean, I think that's not an incorrect reason. I'm not sure that's the actual mentality on why the character class needs to exist. Maybe that's the better way of putting it. Why does the character class need to exist? Go ahead.
They're pre-built power tools for us to like solve a problem, and they're set so us as the programmer don't make stupid mistakes while we're trying to.
Okay, well, that's basically what he said. Remind me, what are primitive types? I guess people weren't listening to Sarah when she said it the first time, maybe.
They just hold values.
They can only hold values. They can only hold values. They can only hold values. They can only, I'm an infinite loopy thing here, and I'll break out in a second. They can only hold a value. What does the character class do? Does it? What does isLetter do? isLetter, I provide it with a char, and it tells me whether or not that was a letter or not. Why do I need that? I mean, might it be helpful in some program in some far-off universe for us to be able to ask, is this char a letter? I mean, I could do that myself, right? I can ask the question of whether or not it's in the right range of Unicode numbers. But that would be inconvenient. The last couple minutes we had several comments about convenience, right? It would be inconvenient for us to have to write the algorithm for comparing the Unicode value of, is this particular char in the range of these Unicode values? That's for isLetter. IsDigit is it in the range of these Unicode values? A different set of Unicode values that are the characters between 0 and 9, right? So, why do these guys exist? Go ahead.
Is the primitive type stored in the class, in its class? Like it's a field of the class?
I'm not going to answer that yet because it'll move me away from the point I'm driving home here. So for right now, I'm going to say no. They actually do give us a convenience. But for right now, the correct answer is no. These guys do not know how to store characters. But do we need a way to store characters? Well, do I need another way of storing characters? Or do I already have a way of storing characters? How do I store a character? With a char primitive type. I already got this beautiful tool sitting here called a char primitive type. And I can give him a char and he knows how to store it. In fact, that's all he knows how to do. Okay? I mean, he's not all that talented, but what he does, he's pretty good at. Make sense? What can't he do? What can't the char primitive type do? Well, it actually kind of sort of does store an integer, but because chars are implemented as integers, but keep moving past that. It knows how to store a char. It can store something. What can't it do? Go ahead.
It can't do anything with that chart. It can't concatenate stuff with it or turn it into a number.
Yeah, it can't do other things because it only stores it. That's the end of its talent. Now, might we want to do things to chars? Might we want to ask if a char is a letter, ask if a char is a digit, so on and so forth? We can think about the zillions of problems we're ever going to solve in our career. Might there be times when we might want to do something with chars that go a little bit beyond the capability of just holding it? Sure. Hence, the existence of the character class. The Java people said, you know what? It might be convenient for us to provide a class that allows us to do things, to operate on char primitive types, because char primitive types cannot operate on themselves because they can only hold a value. That makes sense? Now, since they can only hold a value, the char primitive types, we can say that we don't actually need the character class to be able to hold chars. We just need them to be able to operate on a char. That makes sense? So they don't need to be able to hold chars, they need to be able to operate on a char. So an interesting thing here, and actually I'm going to show an example here first. We're going to pretend like we're done with our fraction stuff just to give me a nice clean canvas here. Well, we actually are done with it for now. So I'm going to create a string S is equal to hello. I'm going to create a char C is equal to, I don't know, H. And I'm going to say system.out println s.to uppercase. And I'm going to println character dot to uppercase. See. So first of all, we're going to see this work. We're going to get the uppercase version of hello. We're going to get the uppercase version of H. All right. Now, we have a string S. Now, strings, what are strings? Give me some kind of definition of a string. Go ahead.
It's a collection of characters.
Collection of characters. Perfect. Love it. Doesn't get simpler than that. It's a collection of characters. And it happens to be an object type as opposed to a primitive type. And how do we know that this guy is likely an object type outside of us memorizing it? Capital letter. Yeah, typically types that start with a capital letter are object types. Notice that all of our variables here start with a capital letter. These are all our types here rather, are object types. They start with a capital letter. That's not a rule, it's a naming convention. So you can't necessarily take that to the bank. But typically, if you're looking at a type that starts with a capital letter, it's probably a class. Okay, what's the difference between a primitive, well, remind me real quick, what's a primitive type? Only holds a value. So the other kind of types we have are object types. So if primitive types can only hold a value, what would you say is the definition of an object type? Go ahead.
Multiple values?
Potentially. They could also hold 0 values. They don't have to hold anything. What else can objects do? They could potentially hold more than one value. And they could also potentially do what? Stuff, right? They could have functions that operate on those 0 or more values, as well as just do stuff, right? We had a fraction class that just said do something, or a fraction method that just said do something for no good reason, other than just showing some example, right? It didn't operate in any of the values that fraction was holding. It just printed out, I'm a static method. Complete waste of time, but tactically, he was a member, he was a member of the fraction class. Okay, so objects can hold 0 or more values and potentially do more. Let's throw this on a slide. It's probably already on a slide somewhere, but let's really drive this point home. Objects versus primitives. Primitives can only hold a value. Objects can hold 0 or more values and potentially do things beyond holding a value. So we can say primitives only hold a value, objects can potentially do more than that. Fair enough, kind of shorthand for that? Go ahead.
Does that mean an object is made out of primitives?
It's definitely possible. They don't have to be. I suppose that at some level, we haven't talked about inheritance yet, but at some level, it's extremely likely, possibly even definite. I just have to think through it more. That all objects at some level are built in terms of primitive types. That's probably it's not 100% true. It's a mostly true statement. But you might have to go down several levels before you find that. Okay, so we get objects versus primitives. Okay, objects are kind of more powerful, but we don't always need the power tool. Sometimes we just need to hold a char, and that's good enough, right? So I purposely use this example because these are two methods that are both called two uppercase. Now, this is where I'm calling these methods, right? This is the strings version of two uppercase. What kind of method? Well, first of all, I would ask you, what kind of class member is that guy? Is that a field, a constructor, or a method? I already gave away the answer, but I'm going to ask you to tell me how you know. So what kind of animal is the guy I have highlighted there? Field, constructor, or method? Or dog? If you that's my usual thing, like cat, dog, or... Okay, so what do you think? Is this guy a field? Is he a constructor, or is he a method? And how do you know? This should be in our soul at this point. Go ahead. Go ahead.
It's a method.
So-
Well, it has like the period in front of it, so that means it's being called, and since it's an instance in front of it, we know it's non-static.
Okay. So yeah, so she already answered the next question too, but you said it's a method. Why is it a method? How do you know it's a method? Just by looking at what I have highlighted there, how do you know that guy is a method and not a field? Or, well, let's just start with this. How do you know it's definitely not a field? What will fields never have? Parentheses. Fields will never have parentheses. So the second I see parentheses involved, not a field. All right? If there's parentheses, it's either a method or a constructor. Now, constructors are always preceded by what? What will I always see right before a constructor? The new keyword, yeah. So he was saying two things. Constructors always match the name of the class. So their name is always identical to the name of the class that's being constructed. And they will always be preceded by the new keyword. All right, so I don't recognize this guy as a class name. How do we know that this is likely not a class name, whether we recognize it or not? We're going to find out if you retained something from about a minute ago. Go ahead.
It's got a field next. It's being drawn from a field.
Just from what I have highlighted there. From what I have highlighted there, how do we know that that guy is very likely? Go ahead.
It doesn't start with an uppercase letter.
Doesn't start with an uppercase letter. Okay, so what we're actually seeing here is naming conventions in action. Again, I want to emphasize, this is not a rule. And beginning programmers, if you're reading a beginning programmer's code, you have to throw this out the window. Because you're going to see all sorts of crazy stuff. All right, you're going to see the no indentation. You're going to sometimes see the anti-indentation, where they've indented the wrong stuff and unindented the, some of the stuff that I look at, but I always find humor in like working horrifically organized code. It's almost like the student sometimes is like screwing with me. Like they wrote it to look and to make it work. And then they just went through and said, okay, wait till this guy's just started moving stuff. Don't do that. Because I'm grading these things on my phone in a swimming pool. And I'm already having to do too much scrolling. But I would find it funny, at least the first time. Then I might hate you. All right, so the fact that this guy starts with a lowercase letter, And notice here that this is a pretty good naming convention, kind of this is something called Camel Case, if you haven't heard of that before. So typically, method names or even field names would start with a lowercase letter, and typically they would be meaningful. So this guy is to uppercase, so the chances are that it probably converts something to uppercase, kind of reads like a sentence, right? And we started with a lowercase t so that we don't trick people into thinking it's the name of a class. And then we kind of highlight the syllables with an uppercase letter. Those are the camel humps. Get it? Camel case? All right. That's not going to be on a test or anything like that, but if you're ever talking to some one of those people that likes dropping buzzwords, always beware of the folks who drop buzzwords, because they're usually covering up let's just call it stupidity with buzzwords. Not always, but often, huh? Camel case, for example. If you're talking to some programmer, pseudo programmer, and he starts like, "Oh yeah, I'm a big fan of Camel Case and all this other crap," yeah, chances are he's cutting and pasting all of his if statements. Is what I'm getting at.
Big fan of
Big Camel Case aficionado.
There's guys like that, and gals. It's. I tell you what, programmers are it's a bad breed. Let's call it. The good programmers, you would never even know they're a programmer when you talk to them. And this isn't across the board, but good programmers just know and don't necessarily want to fluff everything up with words that try to like lord them over you. Like, people just use crazy vocabulary words. Like, get out of the programming world. And just you go to talk to like somebody at like a McDonald's or something, they're using words that you just know they memorized out of like the hardest parts of the dictionary this morning, right? Like, look, you're not speaking English to me right now. Well, look, I think you actually might be, but not normal English. The physical therapy place I go to, I've had this for years. They have one of those calendar things up there that has the word of the day. That's like supposed to be some big vocabulary word that you have to use, or you're supposed to learn what it means. And sometimes they're interesting, but I mean, when you're using words, we have to use the words that's appropriate for our audience, right? Now, you don't want to be spoken to like a 2-year-old. Right, but you also don't want to be spoken to like you're some sort of linguist. There's a sweet spot in the middle.
Where it's just like simple basic words, just like cat. You should have like super basic ones in the programming one, like just like definition of like cat or like dog or like just super basic.
Well, that's how like kids programming, how it works. When you're teaching kids how to program, you have to keep things basic so they can understand the core concepts. Mm-hmm. I mean, because that's what we're really learning here is the core concepts. We're trying to break past all this extra fluff. Curly braces, dots, all this stuff, they're just in the way. They're important. They're important because of how compilers work and how, interpreting and interpreters work for interpreting the syntax. But the actual coding stuff is hidden underneath all of this fluff. Okay? So, we know that this guy is likely not a class. We know he's definitely not a field because we see the parentheses. We know he is likely not the name of a class because it starts with a lowercase letter. Therefore, he is likely a method name. This happens to be a method that takes no inputs, which is an important thing for us in this little lesson I'm going through right now. He takes 0 inputs, whereas we're just going to peek real quick. This other version of 2 uppercase does take an input. Just leave it at that for now. Just kind of keep that rolling in your mind. We have 2 things that look very similar, yet one takes an input and the other one does not. Okay? So this guy is a method, or we're going to call it Very, 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 actually in this case, he's definitely a method, the way he's being called. Because we don't see the new keyword before it, right? So even if this was a class name, the fact that we don't see the new keyword disqualifies this guy as a constructor. All right, so this guy is a method. All right, now, Sarah told us that specifically it must be an instance method. How do we know that this guy, we already said he's a method. How do we know he's an instance method? You would never have static when it's being called. And by the way, that's the perfect example of why you need to memorize it. Because there is think about today how many times I've talked about the difference between defining it and using it. You will only ever see the static stuff on the definition side. Here we're using it. So how do we know that this guy is a non-static or an instance method?
You're calling it from an instance of
Yeah, we have to look at who's calling it. So in this case, we're looking at the guy who's calling this is S. Now, we got to go through the whole rigmarole again. First of all, how do we know that S is not a class name? How can we write based on just staring at what I have highlighted, how can we strongly suspect that that's not a class name?
It's not uppercase.
No uppercase. Okay, right off the bat, we strongly suspect not a class name. Then we can say, okay, we feel confident in that. Then we go and hunt for this. Well, if he's not a class name, I'm going to suspect he's an instance. Therefore, I'm going to come up here. I'm going to say, oh, I found S. Look, Eclipse even highlights it for you. When you highlight something, it highlights where it came from. Okay, so there's the orange here. So there's S. And S is a variable of type string. And he holds hello. He holds an instance of the string class. He actually holds a memory address which points to this instance of the string class up in memory somewhere. But we can say that S is a instance of the string class. Now this is going to be the stupidest slide ever, but it is an object-oriented term. We have something called ISA. So something is a instance of something else. Well, let's say is an instance of a particular object if, actually we use the math term, if and only if. See, I'm just trying to make myself sound smart. Yeah, it's not a misspelling, it's the double F. It's if and only if. Peons. All right, so something is an instance of a particular object if and only if it is accurate to say that the something, this is where you're going to feel like you are dumber after reading this, is one of those objects. Here's an example. Is string S, well, let's see. Say string S is equal to hello. Is it true that S is a string? Yes, because it is true to say that hello is a string. I will never test you over that, but it is something you might see in some object-oriented programming books, this idea of an is-a relationship. It's something that we just intuitively would just figure out on our own, right? We just look at something and like, okay, that guy's a string, therefore he is a string. Cool. Right? But it is an important connector when we're thinking about whether or not, when when we're grappling with the idea of instance versus non-instance, static versus non-static. That's non-static versus static. I want to keep them in the right order. Instance is non-static. Class is static. All right, so this guy is a method. Specifically, he's an instance method or a non-static method. How do we know? Because he is being called by S, which is a instance of the string class. Make sense? All right, so we're good on that line.
Yeah.
We haven't talked about the why yet. All we're doing is we are decomposing that line. We are looking at this point, we're looking at how it's being used and being able to differentiate what things are based on seeing the syntax. Now, I want to really emphasize here, it might seem like we're beating a dead horse here. I promise you this is in your top 10, probably in the top 3 most important lessons with any let's call it modern programming language. You have to be able to read the documentation because you are not going to memorize the entire language. I promise you. Okay? So you need to be able to look at code and immediately say, I don't know what that function actually does, but I know how to call it. Or I know when I go and look at the documentation how it will be defined. We don't have to know what the tool does to know where we're supposed to hold it, right? Okay, so now we have another guy here. Is this guy a field, a constructor, or a method? And how do you know? Not a field. How do you know it's not a field? Parentheses. Good. So we've ruled out fields. Now it's either constructor or method. What's the next thing that it's not?
Method.
Oy.
Not a constructor.
You're right. It's not a constructor. How do you know it's not a constructor?
Because there's no new.
No new keyword before it. Constructors are always preceded by the new keyword. How else can you tell it's probably not a constructor? Yeah. First constructor, the first letter is lowercase, and constructors always match the name of the class. Therefore, they would very, very, very likely start with an uppercase letter. Okay? But the real official way of saying that it's not a constructor is the new keyword in Java. But we do need to be careful of how that travels, because we've seen how we construct objects in Python, for example. There is no new keyword. So we can't look for the new keyword in Python to know whether or not something is a constructor or not, because it doesn't exist in Python. But in Python, the constructor always matches the name of the class. In Swift, there's no new keyword. It always matches the name of the class. In C#, there is a new keyword. In C++, there's no keyword, but it matches the name of the class. All right, so we do need to be a little careful about how this travels, but this philosophy, this cadence of looking at something and decomposing what it is, resolving it in our own brains, is an important thing. Now, we're being slow about it right now, but I promise you this will become second nature. We immediately look at this guy and says, this guy must be a method. Why? He has parentheses and he's not a constructor. How do I know he's not a constructor? Couple of pieces of evidence. No new keyword is from a Java perspective, the definitive one, and doesn't start with an uppercase letter, so probably doesn't match the name of a class. This dude's a method. That's what he is. All right. Then we ask the second question. What kind of method is he? Is he a class method, that is a static method, or is he an instance method, that is a non-static method? Which of those two is he, and how do you know? We ask the question, who is calling him? So in this case, who's calling this method? Is this an instance or is this a class name? Class name, how do you know? Uppercase. Okay, that's the class name. So if it's the class name, if it's the name of a class calling the method, that method must be what kind of method? A static method, okay, or a class method. So if I were to go and look at this toUpperCase method in the character class, I should find static in front of it, right? And we have that up here. Here's toUpperCase, and we see static out front there. Make sense? And if I go to the string class, and I go to toUpperCase, I'll see non-static. I'll see non-static. Oh, I don't have enough tabs?
I thought that was your favorite bar, and I was like, wait, those are tabs.
Well, you guys don't open that many tabs?
I think my computer
Is there?
Yeah, on
Or
the
you
left side.
Oh yeah, the front, yeah. Like,
Oh, that one's
yeah.
pinned too. All right, so do we see here? This is the toUpperCase method in the string class. This guy does not have static in front of it, which is accurate. We predicted that because we looked at this toUpperCase. Notice that he is a method. He's being called by an instance of the class. Therefore, he must be a non-static method, and we proved it to ourselves by looking at the documentation. Make sense? We looked at this version of toUpperCase, say, oh, it's a method, but he's being called by a class name. Therefore, we expect, if I went and looked at the documentation for this class, I expect to find a method in here named toUpperCase that has static in front of it. Right there, static. Make sense?
Yes.
Go ahead.
Even though like string isn't a primitive type, how come they don't keep it consistent with having, like for example, a toUpperCase be an instance or not an instance, a static method?
I'm glad you asked. That's the very next thing we're going to talk about.
All right.
Yeah, because remember a few minutes ago I said, isn't it interesting that one of these guys takes a parameter and the other one does not? Remember that?
Yeah.
All right, so now my question would be why? Why? Let's just talk about the second one first, right? We'll come back to string, because string is the specific question. He's saying, well, why didn't they keep it consistent? Okay, and the reality is that he answered your question about string earlier. Okay, and we'll connect those dots. So in this case, this is a class method, right? A static method. Why does he take a parameter and this guy does not? We saw that both of them boil down to the uppercase version of the thing that called them, right? Or the thing that they operate on, let's say that. So hello is the uppercase, this is the uppercase version of this guy, the thing it was operating on. And the H is the uppercase version of this thing, the thing it was operating on. Why does this version of toUpperCase, the one that's owned by the character class, why does he require a parameter? Can't I just say this?
No, because then it won't know what to actually
Because the string
make up
isn't-
a case.
Don't worry about the string thing for now. We're only looking at this dude. Okay? So if I wrote character.toUpperCase, just like that, forget about the red squiggly line saying this is very wrong, okay? Why will that never work? Go ahead.
Because you're just telling it what type of primitive to make uppercase. You're not actually passing it something to make uppercase.
Okay? So remember I kind of called these guys like factory methods earlier, right? They exist one time. So I'm walking up to this house on the hill, the character house. I'm knocking on the door and I'm saying, hey buddy, I need you to make me something toUpperCase. But I'm not throwing anything through the door. What do I expect him to give me back?
Nothing.
Nah.
He doesn't know what to give back.
I didn't give him anything. He needs me to give him a char for him to convert it to uppercase. Right? He doesn't hold a value. We already have ways to hold char values inside of char primitive types. So I have to give him the character that I want to convert to uppercase. Make sense? Because he is a class method, because they chose to make him a class method, and the reason they chose to make him a class method is because we already have ways of operating on, we already have ways of holding char primitive types. All right? So we made a single class method called toUpperCase, made the class own it, because we didn't have to rely on the class itself holding the value, the unique values of this. So we're saying, look, this guy knows how to convert a given char into uppercase. So I will give him that char, and he will spit out the uppercase version of that.
Can you not do just C dot to uppercase, or is it not because it's not going to the class?
All right, so tell me why I can't say C dot to uppercase. What is C?
Oh, I guess then it won't know.
No, we got to go down the path. It's only a learning experience. We go down the path. What is C? Tell me what C is.
The primitive type.
Primitive type. Tell me what are primitive types.
They only hold value.
They can only hold value. So magic tricks like these are not in the cards. Make sense? Now the important thing with all of this is every single one of these things is explainable. You never, ever, ever want to operate with coding, well, really with anything, and just say, oh, well, it just works that way. That's a bad explanation. We want to know why something functions that way, because typically knowing how one thing works will explain the next 10 things. Okay? So we can't say C dot to uppercase because C is a variable which holds a char primitive type. So when I resolve this, this is equal to H dot to uppercase. This guy is a primitive type, and primitive types cannot do anything other than hold a value. Okay? So since they can't do that, we need something like this in order to conveniently operate on those guys. All right? So then, to answer his question, why is this version of toUpperCase, why does that guy not require any input?
It's an instance of that class, so it knows what it's calling from.
Yeah, what's S?
It's a string, and strings aren't they already imported into Java? So,
They are, but it's not the reason here.
So with that, why is that right? Or no?
Well, it depends. You kind of mumbled it, and
I don't know. It's like the instance of that class, so it already knows what it's taking in.
yep. So because this guy is an instance method, because he's an instance method, he knows about the unique values of the instance that calls him. Okay, and that's what you were talking about earlier, right? So this copy of toUpperCase knows about the contents of S. And because he knows about the contents of S, when I say S dot toUpperCase, he doesn't need me to throw him any information because he knows what he's operating on is the value contained in S, which is hello. Okay, so it's not an inconsistency, it's a nature of who's calling it. In this case, I'm calling it with the name of a class, which does not have a value associated with it, so I have to give them one. But in this case, strings already hold some data. In fact, they're kind of like our bread and butter of, let's call it Java programming, but I would say they're pretty much, the strings are the bread and butter of programming. We use them a lot. So strings and numbers are kind of our two cool kids. But actually numbers, I guess, is the core of all those, because strings are collections of chars. Chars are numbers that represent values on the Unicode character set, which kind of goes back to what he had said at the earlier in class, is everything kind of built on top of primitives? And the answer is yes, and that's kind of the definition of the word primitive, built on top of those things, right? All right, so toUpperCase does not need an input. Why? Because he's an instance method, therefore the instance that's calling him provides the data that he might need to operate on. Now, does that mean that all instance methods will never take a parameter? S dot char at 4. So S is an instance. Char at must be a method, right? We see the parentheses, doesn't start with a capital letter, no new keyword. So this is an instance method because it's being called by an instance. I'm passing it a value. This says give me the character that lives at bucket 4 in the calling string, which will give me the O, bucket 4 of hello. That makes sense? All right. So let's see. Let me look at the book here real quick. So for today, you read up to what? But you didn't. You didn't do unit testing.
No.
You read up to, but not including 7.8.
Oh, I did. I read 7.8 too.
I read 7.
Okay, so that's fine. Let's see.
You just assign 7.8. There we go.
Extra couple of days at 7.8.
I was checking this earlier. It's like 20 different lessons.
All right, so for Thursday, we want to go from wherever you left off. So either 7.8 or 7.9. Make sure we are going to talk about unit testing. It's an important thing that employers actually ask for very often. In fact, you probably heard it, I think, at both of the first 2 tech talks. Maybe they called it regression testing. They may have referenced it as that. Okay, so make sure you read 7.8, and we're going to go up to and including 719. And what you're going to find in here is we've already talked about several of these things. And including 719. So 7.9 through 7.19.
RIP.
All right. What, is that going to be bad?
Wow.
I can give you a hard homework assignment instead. It's going to take less time than the program I'm going to give you over the weekend. We're just not quite at the program part yet. All right? Everybody get it? I'll put up an assignment for this so you can put in the 1-page summary type thing. Okay? So I'll put that up. So 7.9 through 719. I'll see everybody on Thursday. Today, student, faculty, staff, Bible study, God and grub. Go to the cafeteria, sign in, take your tray down to the terrace room. It's from noon to 1.
I need to start doing this so my screen doesn't get worse.
But they
It's
would
starting
work
to get
most